As a quick aside, in my personal experience, I struggled for the longest time with quickly grasping what a reduction or an oxidation was because the terminology was not intuitive to grasp for me. It always used to take me a minute to identify which reaction was which, and I'm sure that some of you might be in the same boat. What I eventually grasped over time is that as a whole, oxidized substrates become less complex and reduced substrates become more complex. For example, glucose, through the process of glycolysis, becomes less complex as it gets broken down to pyruvate, and this pathway represents an oxidation. Inversely, acetyl-CoA is a small molecule of a few bonds if we exclude the CoA that gets taken off, and it can get reduced to produce fatty acids, which are long chains of hydrocarbons. By the way, given the space constraint of the map, the R in the fatty acid is a shorthand for all the long bonds. This idea of complexity can even be seen in the oxidized and reduced forms of NAD and NADP. Indeed, although it is minimal, NADH and NADPH are more complex than NAD and NADP because they both have an extra hydrogen and thus make the reduced version more complex. Now, for something to gain complexity, or in other words, get reduced, something else must get oxidized or lose complexity. This is where NAD and NADP differ in function. If we first consider NAD and NADH, their ratios in the cell indicate that there is much more, about 1,000 times more NAD than NADH. This large amount of NAD can then get reduced to NADH in order to oxidize the substrates. So, as you can see in the example boxed on the left, malate gets oxidized to oxaloacetate as it loses that hydrogen to the newly formed NADH. On the other hand, NADPH outnumbers the amount of NADP by about 100. This high quantity of NADPH gets oxidized to NADP and in the process gives away its hydrogens to reduce substrates. The example in the green box on the left illustrates this as the oxygen gains in hydrogen given by NADPH. An alternative and more scientific way to talk about the complexity that I've kept mentioning is to say that oxidations are a loss in electrons and reductions are a gain in electrons. Since electrons are shared between bonds, an oxidation will typically involve losing a bond, and a reduction will make substrates gain bonds. So, to reformulate this idea one last time, oxidations cause the loss of complexity, or electrons, of a substrate, and this is accompanied by the reduction of NAD to NADH.